Hello everybody, welcome into another lesson. So today is the final lesson of 2D geometry. Then we got 6 more lessons after this left in pre-algebra, which will all be 3D geometry. So we're fastly approaching the end of pre-algebra, then we'll be into algebra 1. But what are we doing today? We are going to find the area of composite figures. Composite figures are something such as this, where you have two shapes fused together that creates a unique shape. And every composite figure is unique in how you're going to evaluate them. Here we clearly see what looks like two rectangles put together. You have a rectangle here with a length of 12 feet, a width of 4 feet, and then you can draw an imaginary line to separate this rectangle here. You'll have another rectangle with a length of 4 feet, a width of 6 feet. In order to find the area, you just gotta find the area of both of these shapes, both of these rectangles, and add them together, and then you get your total area. So this will be area sub 1, this will be area sub 2, because we want to find the area of each of these rectangles separately first. So area 1, that's equal to the length times the width, which would be 12 times 4 feet. 12 feet times 4 feet. Right? To find the area of this rectangle here, well, area 1, 12 times 4, that's 48. Feet times feet, that's feet squared. So we got the first area being 48 square feet. Let's find the second area of the smaller rectangle. The smaller rectangle will take that length of 4 feet times the width of 6 feet. Okay, so then we have 4 times 6, well that's 24. Feet times feet, that's feet squared. So we got both areas now. To find the area total, A sub t, we're going to call it that, A sub t, the total area, you're just going to add the sum of both areas together. So the total area is the sum of these areas together, which is going to be equal to that 48 square feet plus the 24 square feet. Well, 48 plus 24, that's 72 feet squared. Well, it still stays feet squared. So the total area of this composite figure is 72 square feet. I did that by drawing an imaginary line here at this edge and separating out these two rectangles. And then I took the area of the two rectangles separately, and then I just add them together. I got an area of 72 square feet. And I do have more. I got 3 more examples here. We get some interesting shapes when we deal with composite figures. Basically, think of this as a grand review of everything we've done so far. You're just putting it all together. Alright, I'm going to take the book here and trace this. Alright. We got an interesting shape here. We have a rectangle and a semicircle that seem to be fused together to form one shape. Looks like a little carrying bag. almost, is what it looks like. We got a length for the rectangle being 10 kilometers. The width is 4.3 kilometers. We got the diameter of the circle being 5 kilometers for the whole diameter. This would be the center of the semicircle. There's the center of the semicircle right there. Okay, so what we have here, we have a square and a semicircle, not a square, a rectangle and a semicircle joined together. What we got to do then, apparently, is we got to separate the semicircle from the rectangle. We got to find the area of each of these individually. I'll call the semicircle area 1. I'll call the rectangle area 2. Okay, so let's find the area of the semicircle. Well, a semicircle is half a circle. To find the area of a semicircle, you're just going to take half the area of the circle. So that would be 1/2 times pi r squared. Right? 1/2 times pi r squared, because it's half the area of a full circle since it's a semicircle. That only makes logical sense. Let's do some work on the side over here. We got the diameter is equal to 5 kilometers. We need to find the radius. The radius is equal to half of the diameter, right? So then the radius would be equal to half of 5 kilometers. So that means the radius is going to be equal to 2.5 kilometers then. Because in order to find the area of a circle, we need to use the radius. I mean, we can use the diameter. You're just going to involve an extra fraction, and I don't really think anyone wants to deal with any more fractions than they have to. So this area is going to be equal to 1/2 times pi times that radius of 2.5 kilometers to the second power. Which order of operations dictates we do the exponents first. So you'll have, sorry, my phone. I thought I shut off my alarm. I'm sorry, folks. Okay, so you have 1/2 times pi. So then 2.5 squared, that's going to be 6.25. Kilometers squared is going to be just that, kilometers squared. Okay, so what we got to do now is take 1/2 times pi times 6.25, and we'll get the area of the semicircle. So let's get my calculator out. 0.5 times pi times 6.25. To round to 2 decimal places, I get about 9.82. I get about 9.82 kilometers squared. That would be for the first area here. That would be for the area of the semicircle, is about 9.82 square kilometers. Because again, an area of a semicircle is just 1/2 the area of a full circle. So that's how we got that. Alright, the second area is going to be easy because it's just a rectangle. All you got to do is take that length of 10 kilometers times that width of 4.3 kilometers. Well, we know 10 times 4.3 is 43. Then kilometers times kilometers is kilometers squared. So the area of the rectangle is going to be 43 square kilometers. Now we want to find the total area. The total area is nothing more than the sum of these two areas put together. It is denoted by A sub t being the total area is equal to the area 1 plus area 2 put together. Just add them together. So the first area was about 9.82 square kilometers. And then your second area was 43 square kilometers. So if we add these together, 9.82 plus 43, we get 52.82. You get 52.82 square kilometers for your total area of this abomination of a figure. You can get, again, composite figures can get very interesting very fast because they're a mix of shapes. They're not normal shapes. So that's how we get all kinds of stuff. Alright, I got two more examples here, then we're through. Why am I drawing this? Well, because on these ends you got semicircles. So it looks to be that we're going to have a square bounded by two semicircles put together to make a very interesting shape. Almost looks like a heart. It almost looks like a heart in a weird way, just a tilted heart. But the length of these sides of this, why am I saying kilometers? It's inches, excuse me. I want to get the units right. Okay, so we know we have a square here. We got a square. Well, it looks to be that the diameter of each of these semicircles is also the length of the side of the square, the way these bound each other. So I'm going to fill all these in just to help us out here. Put the center of the diameter here, the semicircle. Okay. Well, here's my recommendation. We got a square. I think that's a dead giveaway. That's going to be area 1. Now there's a couple things we can do. We can take the area of each of these semicircles separately, or we can use the fact that if you have two semicircles with the same diameter, they got to have the same diameter and radius, which both of these do. Since they both have the same diameter, we can use the fact that two semicircles of the same diameter, when you put them together, they form a full circle. So this will be A sub 2. This will be area 2. We're going to put both of these semicircles together to form one circle. You can save yourself some work. If instead of trying to find 3 areas, you could find 2 areas. So let's do the area of the square first. I'm all for that. Area of the square is just going to be that 3.2 inches to the second power. So now let's find out what that is in my calculator. .2 to the second power is 10.24. I get 10.24 when I take 3.2 to the second power. Then inches to the second power is just that. So the area of the square is 10.24 square inches. Now we want to find the area of these two semicircles, which we can honestly just put them together and make the area of one circle. If we remember the area of a circle, you have two diameters here, which would just be one diameter if you're putting them together. The area of a circle is pi times the diameter, which would be equal to pi times that diameter of 3.2 inches. Did I say the area? I meant this. I was thinking of the circumference. Forgive me, folks. Forgive me for that, folks. That's the circumference. The area is pi r squared for a full circle. I'm glad I caught that. Thank you, guys. So it'd be pi times, we need to find the radius. We know the diameter of this circle, the two semicircles joined together, is 3.2 inches. The radius is equal to half of the diameter, which would have to mean it's equal to half of 3.2 inches. Half of 3.2 inches is equal to 1.6 inches. So the radius is equal to 1.6 inches. Okay? So what we got to do is take this pi times that radius of 1.6 inches, raise that to the second power. First things first, we got to do the exponent, so we'll take 1.6 to the second power, which I'm pretty sure is 2.56, I want to say. I want to say that's what it is. 1.6 to the second. Yep, I was right. It's 2.56. So you'll have pi on the outside. On the inside of the parentheses, since we took 1.6 to the second power, that'll be 2.56. And then inches squared, well, that's just what it is. Square inches. Inches squared. Now we just got to take pi times the result. We can get an approximate area for the two semicircles, which we joined to make one circle. Since they have the same radius and diameter, we can do that, make it into one circle. So we take 2.56 times pi, we get about 8.04. So get about 8.04 square inches for the area of the two semicircles, which we just combined into one. Now we want to find the total area. You're going to add the first area with the second area, which would be equal to C. Area 1 was 10.24 inches squared. Plus area 2 is 8.04 inches squared. So we take these and add them together, you would get 18.28 inches squared. Add the sum of the 10.24 inches squared plus the 8.04 inches squared, you would get 18.28 inches squared for the total area of this composite figure. And I do have one more. I do got one more. This will be a fun one. Because the way it's looking, I'm pretty sure we're going to have at least two areas. Now we're going to have three areas. we're going to have 3 areas we got to add together. For the next one, alright, what does this entail? What does this one entail here? Of course, we'll form a nice I can't draw straight to save my life. Alright, so we got this wonderful thing here. The length of the top part, let's see, 17 meters. Got this width being 3 meters. This length here is 8 meters. See, this length is 4 meters. This length is 12 meters. Okay. Right angle. Alright, so we got this wonderful shape here. Well, how the heck are we going to solve this? I can clearly tell you here what I would do. I would create an imaginary line and make this top part a rectangle. I would certainly do that. Okay. Then I would take, at the bottom here, it clearly looks like you could form a triangle. So what you're going to have are 2 rectangles and a triangle. That's what it looks like we can form. I will call this first one here area 1 for our first rectangle. Our second rectangle will be area 2, and then the triangle, that'll be area 3. Alright, let's just focus on the first area real quick. The first area, it's a simple length times width, which would be 17 meters times the 3 meters, which means 17 times 3, that's 51. Meters times meters, that's square meters. So the area of this top rectangle is 51 square meters. That much we got settled. Alright, let's look at area 2. Well, if you go to where just from the top of this rectangle to where the second rectangle ends to where it meets the triangle, it's 12 meters. This length here is 12 meters. If you want to get your length and width to solve area 2, what you're going to have to do is take that the total of 12 meters minus this length here being 3 meters, since it's a rectangle, you'll take 12 minus 3 because we're taking away this part since we've solved it. You'll get just this part here being 9 meters. So just this segment here in this rectangle is 9 meters. And then we want to get this length here. Well, we know the total, since it's a rectangle for the top part, the total length of this going across would be 17, but we're taking away this part here, the 8 meters, because we want to just have this length up here for this rectangle, which actually looks like it's turning into a square, because if you take 17 minus 8, you also get 9 meters. So it looks to be that we actually have a square instead of a rectangle. How I did that was the total length from the top of the first rectangle to the bottom of the square is 12 meters. Well, I just want to get the length of the side of the square, so I'm taking away the length, I'm taking away the width of the first rectangle. Take 12 minus 3, you get 9 meters for the length of this one side of the square. To get this length of the side of the square, I take 17 minus 8, since opposite sides are congruent. Take 17 minus 8 away, you'll get 9 meters. So to find area 2, we're just going to use the formula for a square, which is just take one of these sides and set it equal to the second power. Well, we know 9 to the second power, that's 81. Meters to the second power is just that. So far we found the area of the rectangle being 51 meters squared. We found the area of the square being 81 meters squared. Now we need to find the area of the triangle down below. Well, we can settle this here for the base. The base of this triangle, since it also forms the edge with this square, is 9 meters. The base of the triangle is 9 meters. The height, when you go from the end of this square down to the bottom where it would meet this vertex of the triangle, is 4 meters. So the height's 4 meters. So let's find the area of the triangle here. Remember, area of a triangle is half the base times the height. So half of 9 meters times the height of 4 meters. Well, we know half of 9 is 4.5. So what you'll have is 4.5 meters times 4 meters. 4.5 times 4 is 18. And then meters times meters is, well, meters squared. So the area of this triangle is going to be 18 meters squared. So now what we got to do to find the total area, just take the area of each of these, just add each of these 3 areas together, you'll get your total area. So let's go ahead and do just that here. Total area is equal to area 1 plus area 2 plus area 3. So yes, composite figures means at least 2, sometimes more shapes joined together, as we see here, to form one big figure. So you probably hear that thunder. I didn't know it was going to storm, but I guess it is. But anyway, area 1 was 51 square meters. Area 2 is 81 square meters. Area 3 was 18 square meters. I know my writing goes off to the side, I apologize. But now all I gotta do is add these up, we'll have the total area of this figure. 51 plus 81 plus 18. That'd be 150 square meters. If we add them all together, you'll get 150 square meters. That sounded just delightful out there. Getting a lesson and a show, huh? Well, so the total area of this composite figure is 150 square meters. So once again, what I did is I separated this into a rectangle, then a square, then a triangle. They gave you the total length of this side until it meets at the triangle being 12 meters. I was able to do 12 minus 3 to get the length of this side of just the square, since we weren't factoring in the whole length. We got the length of the square. Then we got the width of the square, or another side length. I just took 17 minus 8. I got that side being 9. Then, of course, we could use the fact that in a square, all 4 sides are congruent to give you the base of the triangle being 9 meters. Composite figures, you just you look at the overall shape and see what you can separate it into, you're going to have a lot of imaginary lines. You're going to have several areas you got to add together. But to get the total area, you add up the sum of the areas of the shapes you split it into. That's basically it. So that's been it for 2D geometry. The final 6 lessons we're about to do of pre-algebra are going to be 3D geometry. So stay tuned for that. I hope everybody has a good night. Take care.